All right, great. Today we are looking at operators in R, quite a number of them. Quickly, let me share my screen and let's look at operators in R. Very important. All right. So this is what we want to be looking at. No, don't worry about this. This is what I'm actually going to want us to look at. Operators in R. So in R, we have different operators. We have arithmetic operators, we have relational operators, we have logical operators, and assignment operators. We're going to look at that pretty soon, and we will all see how this works. So this is my R, and this is actually where I'm doing my R tutorial. I'm actually going to clear this console. So Control L will clear the whole thing. And when I come here, because I'm going to begin a new session. Let me pull this down so that you can see everything clear here. So I'm actually going to do just what we call operators in R programming. Yep. Um, so I will be alternating. So these are the operators we have. I'm going to start with the arithmetic operators. There are quite a number of them. Maybe I should move. I'll move to the next slide. We have addition operators, subtraction, multiplication, division, modulus, then exponent, and of course, what is it, a floor division. I will not do floor division. I may not do I will do exponent, but I may not do this one for today. I will also try and do relational. What is it? I'll look at the relational operators like equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. I think I've done this, but maybe we haven't paid attention to it. So let's get back to the studio and then look at something. So I'm going to create some few vectors. So I have let's say I have this. I've already created quite a number of vectors, and then so I'm going to call this one vector 1 1, and then I'm just going to assign some values to it using the combine. So I'm just going to create, let's say I have 33 and in that order. So I've done this. Let me create another vector. Let me call that one VT22. And then I'm already doing one of them. What you are seeing here, this particular thing you are seeing here is called assignment operator. It means I am assigning everything on my right hand side to my left. And then we can do that in different ways. But before I get there, you would have had a clear example of what I'm doing. So if I come here, I can actually say, all right, how many things I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can actually say that I have, let's say, 1, let's say, is to 9. And then that's also going to work. Then I can actually create another vector here. And then let me put that VT33, then also assign, let's say, and create another, I don't know, something. Or let me just say 8. I'm sorry about that. Let me just say I want to do 8 to 15. 8 to 15. Or let me say that I want to repeat 8. So I can use the repeat function. I want to repeat a particular number, let's say 9 or 8, and I want to repeat it how many times? 9 times. So if I do all these things, if I run all of them, they should run. They have run all right. So I'm going to be alternating from here. We're going to do the addition. The addition means we can actually add two things. You can add one vector to the other. So let's get back to the studio. So if I have the first vector, so for here, let's say that I'm dealing with what is it? Addition. So I can actually add one vector to the other. So I can actually say that VT11 and then I just put my operational sign there and say VT22. And then if I should run this, it should add whatever that is contained here. It's going to add these two vectors. So what it's going to do is that it's going to add the first value to the second. The first values will add, the second values will add, the third values will add, and that's how it is. So that means that in doing arithmetic operation, the vector should contain the same number of elements, and that's what I mean. So I can as well add, let's say, VT11 to, let's say, VT33. And then if I run it, that should be able to run. You see that it has also added. For instance, I have repeated this 8 times. This one means that we have 8 up to 9 of them. That's what I have just done there. So we can do this for subtraction. I can put subtraction here, and that is going to work. If I put subtraction there, I can actually run it, then it will run. All right. So it's going to subtract whatever that is here from this place, and then in that order. So I can actually do multiplication. I think I should have left them there. And then I'll just copy and paste. I'll just copy this. And then when I come here, I can just enter there. And then I'll paste it and change the operational sign, which I'm just going to put, let's say, minus. And so when I do that, I can actually see that it has worked. So the answer is here. So you can actually subtract, and then you can put your multiplication here, and then it's going to multiply just like the way I told you before. So that's for this particular part. So addition, subtraction, we can actually also do division. So the division, how do we do that? We quickly come here. So I have, I'm just going to paste and then come and change this operational sign to division. And it's actually going to divide it. So it will just divide everything like this. And all of them, if you want, if you get the answer, you can actually also assign the answer to something else. And then that's how it is. Then you can also check for this particular operational sign we call modulus. Now, the modulus, let me explain what that means before we get in modulus. What you are simply saying is, when we're doing number bases some years back, when you do, let's say, you have your number basis, when you say 7 divided by, let's say, 5, you don't write 1. 7 divided by 5 will give you 1 remainder 2. So in modulus, you're actually looking for the remainder and not the actual value. And so we use this thing when you are going to find out whether a number is even, is a multiple, or is something like that. Because if I divide any number and the remaining is 0, it means that they are multiples and in that order. So we use modulus a lot. Modulus are very important. So we can also apply that here. So for instance, if I should paste whatever I have and I come and change this particular, you can see the modulus in R. When you are dealing with modulus, you're actually using 2 percentage signs, and that's all. 2 percentage sign, and that will give you modulus. So my operational sign there will be 2 percentage, shift and 5 on your PC will give you that. And when I do that, I come and run, then it's going to give me. So it means that when I divide vector 11 by vector 22, these are the remaining. So for the first one, if I divide 33, by 1, nothing will remain. It will give me 33, remainder 0. So we can see 0 over here. And these are the results. So let's look at what other operation that is there. Exponent operation. We can actually say A exponent B. Let's go try this and then see what is going to happen. So I have, I'm going to paste this again. Then when I come here, I'm going to press Shift and 6. That's going to give me exponent. And then you can see the results here. What that means is that I'm looking at these two vectors here. So, and I'm saying that 33, what is raised to the power, maybe whatever that is also corresponding here. 55 raised to the power something, then in that order. So that's something raised to the power the other, something raised to the power the other. So you just put the power sign here, and that's how it is. And then you're going to have it. So let me look at another operation that is there. I told you I'm not going to do the floor, division for some reason. It's not too different from the modulus, but I want to leave that one. The other most important thing in operators in R is relational. Whether something is equal, they are not equal, and then so let's go back to the studio and look at equal, not equal, and then before we come back and look at. So I have my two vectors already. So let me get these ones close. I'm going to get that close, get this close, get them close, and of course, get this close. So I'm going to look at relational operators. So let me just hashtag it and say I'm looking at relational relational operators in R. So I have my two vectors already. So let me just, but for the purpose of, okay. So let me just have, this time around, let me deal with these two. So I already have, let me just pull up a little bit. So if I have my vector 2, 2, and then I have my, I want to say equal, whether it is the same thing as vector 3, 3. Now, when you use double equal sign in R, it means that you are finding out whether what is on the left and what is on the right are the same. So indirectly, what we are saying is that I want to find out whether these two vectors, their entries are the same. And what R is going to do is that it will compare them, what is tangentially. So the first value to the first value, second to second, third to third, fourth to fourth, in that order. And see wherever one is greater or whether one is not greater. And so what you are going to get here, it will return a Boolean. A Boolean means it will return either true or false. You just want to find out. So if I run this, it will tell me whether they are equal or they are not equal. So if I run it, you should see that false. It means the two vectors are not the same. So the same way, let me copy it for the purpose of fast. I want to be very fast for this. I just come here and then do this. If I change this, I can actually find out whether they are not equal. In R, if you want to say not equal, you use exclamation mark and then equal sign this way. So let me get back to the operators and then you verify. You see that exclamation mark and then equal sign will give you not equal. So you want to find out whether they are not equal. Obviously, you should know the answer. The opposite is it should be true. So it should return the Boolean, it should return the answers as true, true, true. It means they are not equal. Now, you could actually also find out, let me paste, okay, I'm sorry about that. I actually want to paste it here. Let me paste it over here and come here, change this operational sign to whether one is greater than. So the greater than, you just put the greater than symbol there. And then now in all relational, it will simply return you either true or let me delete this out. That's all. So it will actually just tell you whether false, true, or false. If I decide to also change this to whether it's greater than or equal to, some places they must be the same, some places they might not be the same. So this for, so I can come here and paste it again and come here and say greater than or equal to. So greater than or equal to in R, that's how we do it. Want to find out whether the two of them are greater or so you can see that some are true, some are not. So somewhere you can find true here, somewhere you can find false. So it means some of them are the same, some of them are not the same. As you can see it in the console where I have underlined. So let me pull this down, and then what operational relational sign that is left that I have not touched on, I've done greater than, less than, greater than or equal to, less than or equal to is the same. So that's how we apply operators in R. So we now want to look at assignment operators very, very, very quickly. We have left assignment, we have right assignment, we have equal assignment, and then of course, whichever way you can look at it. So we are going to look at assignment operators. So if I come here, my hashtag, I'm actually going to, let me pull up some small space. Then I come here, put my hashtag. We are going to look at assignment operators. Assignment, or what is it? Operators. And then I come here. The first thing is we can use these two symbols. We can use equal sign, and then we can also use what is it? This particular one. So let's begin with the assignment. So if I have a vector, or what I have done on top here, let me copy all of them. No, let me copy them one by one, just to save time. So when I come here and I wanted to assign the the results, I could actually say that maybe say let's say result one, and then I could use this, all right, and then I paste whatever that I have there. So I am assigning whatever is on the right to what is on the left side. So this becomes a variable. So this is what we call a left assignment. We are assigning everything to the left hand side. So that's where the arrow is pointing there. So if I run it now, I'll package. If I run it now, I have packaged everything here I've packaged everything on my right hand side to whatever is on my left hand side. Now I can print the result one. I can print result one and it will give me the same answer. Yeah, like here. So I package the answer there. We also have the right assignment. So that way I could have actually done pasted this here. I don't know if that will work. I haven't tried that before, but let me try it. And then in that case, I am going to do this and then come and say result 2. So let's see whether if I, so that's the right assignment. You've assigned it to the right hand side. So whatever is on the left, we have assigned it to the right, and that's quite straightforward. So if I run it, I can come here and print result 2, and then if I print result 2, it should give me the same thing. Now we also have the equal assignment. So where instead of using this greater than and dash, less than and dash symbol to indicate an operator, to indicate an assignment operator, we can actually use equal sign. For instance, if I were having, let's say, result 3, I could actually do like this, and then I come and paste this here. So I am assigning everything to this side. I am assigning whatever is on the, or what is here, to the other side. And so mostly when you are using the equal sign, R we always use wherever the command is and assign it to the other side. So for R, it can be either way around, and then you have finished your assignment. So when you run, it will also run. I can print results 3, and it will give me the same thing. That's assignment operators. It's not that too complex. So we looked at assignment operators. Let me get back here. Arithmetic operator, we've done that. We've done relational operators, logical operators. So logical operators, you want to combine two things. For instance, you want to combine two the element of a vector, and then ask yourself whether they are the same. So if you use this particular sign, we call it ampersand, A ampersand B. So it means you are saying A and B. So it combines each element of a vectors and give output true if both the elements are true. So we have also the pipe operator. So it combines each element of the vector and gives an output true if one of the element is true. So this and or is the same thing we were using in elective maths. So for instance, I can say that A and B, it means that I am saying that A and B must, all of them must be equal. So in that case, it will return just a Boolean and say true. But if I say A or B, and it means that the element of A and the element of B are, one of them is true, then it will return true. And then that's how it is. We also have this particular last one. It takes each element of the vector and gives the opposite logical value. Is not A. Okay. So let's go to the studio and try that. For instance, I have two vectors. So I can say my VT 2, no, my VT 1, and then I can put this ampersand sign, which is shift and 4 and put my VT territory. So run this and see what is going to happen. The operator is invalid for atomic vectors. So it's saying that the operator here is invalid for atomic vectors. And maybe I should change another one and see. Maybe 2, 2. And let's see. Yeah, that one too is also, what is it? Invalid. The operator is invalid. So let me use the pipe operator and see what is going to happen. The pipe operator is shift and I don't know how to. Yeah. So the pipe operator, it tells me that it's true. It means that at least there is one element in both vectors which are the same. There's at least one element in, what is it, in either vector 1, 1 or vector 2, 2, which are the same, or which is the same, or which is true. So at least one of them is true. That's what that means. But if I had used the ampersand, sorry, the first one I was using was not ampersand. I was actually using percentage. I didn't pay attention to that. Sorry about that. So this is the ampersand. It's actually, what is the symbol? Shift and 7. Shift and 7. So when you run that, it also says true. It means all of them are the same. Or all of them, what is it, may be equal. And that's what that means. So it also returns true, 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 true. And the last logical operator that we have is this exclamation mark and A. It takes each element of the vector and give the opposite logical value. Then let me try this and see if that will work. And then I can actually get back to the studio. All right, so I have let's say I have, where is it? All right, this, and then let me just add VT. What is it? 1, 1. Then run it and see what I'm going to get. Yeah, it's a false. It's a false. So that's basically how we are able to use some of these operators to, to authenticate whatever that we're having there. If it were these operators, we can actually apply them in what is it? Whether it's in matrix, it's in array, or it's in data frame. The most important thing is to know the columns or how to identify the figure, and then you can do whatever. For instance, I don't know whether I have a data frame here. If I were having a data frame, I would have actually tried one there. I don't know if I have a data frame somewhere. I wish I had one somewhere in the tutorial so that I could use that to demonstrate how. Okay, I have a data frame here, which is actually not a data frame. I think is an array. What I want is a data frame so that I can simply demonstrate how to. Yeah, I have a data frame here, which is called my data 1. If I run it, oh, the objects are not there. I'm sure I have changed some things, so it's definitely not going to work. So let me run all this bulk, right? Everything run. Then now let me come here and then run my data frame. So yeah, I have changed some few elements there, and then that is the problem. Let me come here and run this. Yeah, I've changed some things there. That is why. So, but later on, we'll be looking at how to apply what is it? Operators in R, but not on ordinary vectors, but on data frame, on matrix, and then on arrays. And we'll see how we can do that. Data frame mostly is how to be able to locate the column or how to locate the cells and apply the mathematical operation. And it will work just perfectly. You can apply any mathematical operation on data frames and whatsoever. That will be our next video. So for now, I'm going to leave you here, and I hope to see you some other time. Thanks very much. My name, as usual, is Big Bright. Thank you. God bless you. And please don't forget to subscribe to my YouTube channel. I'm going to be uploading a lot of simple things in data science and these languages that we are I'll be doing quite a number of them. I have some in Excel, some in Python, and then others too in Linux. I will be doing them systematically. So follow this channel and trust me, you're going to learn a lot. See you some other time. Bye bye.